In this section, we are going to study the scales of measurement. Now, first of all, the types of variables. The variables may be discontinuous or continuous. So we have two types of the variables on the basis of their scales of measurement, discontinuous or continuous. So discontinuous variables are those in which values assume integral whole numbers, and they're usually count of things. And the continuous variables are those in which values in principle may fall at any point along an uninterrupted scale, and these are usually measurements of things like length and mass, etc. So these are two types of the variables, continuous and discontinuous variables. And in discontinuous variables, because these are usually the count of things, so the values or the observations that we have on the discontinuous scale, they are the whole numbers, right? They are the whole integral numbers, and they don't have the intermediate values. Like you can have a count of 1, 2, 3. You cannot have a count of 1.1, 1.2, or 1.3, or 1.4. So this is an interrupted scale. This is discontinuous, on which you have the absolute numbers and whole numbers, right? The 1, 2, 3, 4, 5, 6, 7, and so on. While on the continuous scale, you have the intermediate values, and you have an uninterrupted scale, and your values may fall at any point. They may fall on a whole number, or they may fall on an intermediate number. And sometimes the continuous values, they may be rounded off. For the ease of representation, they may be rounded off to the whole numbers, but that doesn't mean that their intermediate values do not exist, right? So these are the two types of the variables, the discontinuous or continuous variables. Now, the data that we obtain through the discontinuous scale of measurement is usually known as the count data, because that involves the counting of things. And the other data that we obtain through the continuous scale of measurement is known as the measurement data. So these are the two types of variables. Now we are going to discuss the levels of measurement, and there are generally 4 levels that have been recognized for measurement, and each level has its own rules and perceptions. And each level is hierarchical, which means that each new level incorporates the properties of the scale which is below it in addition to its own specific properties, right? So there are generally 4 levels, and each of these levels has its own unique properties, and each of the new or the higher level is going to incorporate the properties of the level below it as well. And these are those 4 levels. The most basic one is the nominal scale, then ordinal, interval, and the highest scale is the ratio scale. So these are the 4 levels, and these are hierarchical levels, right? And each one have its own rules and perceptions, and each level is hierarchical. So these are the 4 levels of measurement. Starting from the most fundamental or the most basic scale of measurement, which is the nominal scale. So this is the first level of measurement, and this is the most elementary scale. And it only identifies categories, right? So it only identifies individuals through their categories, or it puts or classifies individuals or items into categories. Now remember one thing, that whenever I'm referring to individual here in this discussion, I'm referring to a unit in a statistical population. I'm not referring to a living being. I'm not referring to a human being. I'm just referring to a unit in the statistical population, a member of the statistical population. So the nominal scale, it identifies categories only. So it places individuals of the statistical population into different categories, and it is used for their classification. And examples of the categories into which count data can be assigned are species and gender. So nominal scale is basically the count data. So this is discontinuous variable, and this is going to classify individuals into different categories, and it uses the count data. And the examples are species and gender. So for example, you're going to classify some members of the statistical population according to their species, or you're going to classify the members or individuals of a statistical population according to their gender. So these are the examples and in which you can count data. So nominal scale basically involves counting of the individuals into different categories. Now, for the classification of individuals, the categories have to be mutually exclusive, right? Which means that one individual cannot be placed in more than one category. So it means that these categories, they are mutually exclusive and there is no overlap between the categories. So they have to be very well defined and they have to be mutually exclusive so that you can place one individual of a population into only one of the categories. You cannot place individual into more than one category. So they have to be discrete, they have to be mutually exclusive. Like gender, so you can place an individual of the population into a female class or the male class. And similarly, the feeding habits, that you can place an individual of the statistical population into either herbivorous class or carnivorous class or the omnivorous class, right? So they have to be mutually exclusive so that individuals can be classified discretely and exclusively into different classes. Now, the nominal scale, as its name shows, that it involves naming of the categories, right? And in the previous example, we also saw that we were using the naming of categories like female and male gender, and we were using the names of the feeding habits like omnivorous, carnivorous, and herbivorous. But these names can be substituted by numbers. And these numbers, they don't have any numerical significance. They are just label. So you can label them by A, B, C, D, or you can label them by 1, 2, 3, 4. But these numbers or labels, they are just labels and they only identify categories. They don't represent the quantities or numbers. Like in a statistical population of finches, you want to find out the finches which belong to different species, like the small ground finch, zebra finch, house finch, star finch, and woodpecker finch. Now you can represent these categories by the numbers 1, 2, 3, 4, 5, but these numbers, they don't represent their quantities. So this numbering is done only for the ease of labeling, only on the ease of arranging the data, and that's it. Because if you find it hard to write down the complete name every time, so you can just write down their label, which can be 1, or which can be A, which can be 2, or which can be B, which can be 3, or which can be C, which can be 4, or which can be D, or which can be 5, or which can be E. So these are only the categories that don't have any numerical significance to them. So this numerical coding helps in listing 1, 2, 3, 4, 5, and this sequence has no statistical significance. If they are listed at 4, 2, 1, 5, 3, they are still going to be the nominal categories. So nominal scale classifies sample units for counting. So this is the property of the nominal scale, that it classifies the sample units or individuals of the statistical population into different categories. And what it lacks is that it does not involve ordering, that although you classify individuals into different categories, but these categories are not going to be represented in an order. So these categories are not presented into order. So if you arrange them as 1, 2, 3, 4, 5, or you arrange them as 5, 4, 3, 2, 1, it's not going to change their meaning. So this is the most elementary scale, which is the nominal scale onto the scale of measurement. So this is first level. Now we have our next level, which is the ordinal scale. And the ordinal scale, as we discussed, that these scales are hierarchical. These levels are hierarchical, which means that they incorporate the properties of the previous level, the level down to them. So the ordinal scale is next to the nominal scale. So it involves the classifying and labeling function of the nominal scale, but it has its own unique property as well, which is that it brings this classification into a sense of order. So this is the new thing in the ordinal scale. So ordinal numbers, they indicate a rank order, but nothing more. So the nominal scale, we can substitute the number of the names of the categories by the numbers, but those numbers, they don't have an order, and even if you write 1, 2, 3, or you write 3, 1, 2, that is not going to change the meaning. But here in the ordinal scale, the numbers, they have a significance in a sense that they are going to represent the order in which the categories have to be placed. So categories, they have to be classified in an order, and this order is important. So numbers are going to give us a sense of order and nothing more. Again, these numbers, they don't have a statistical or numerical significance. They are only showing their relative ranks of different classes or different categories. Examples are like consumer satisfaction for a product. So consumer satisfaction for a product, it may range from highly satisfied to highly unsatisfied. The abundance of species, that may range from abundant to rare, or the class rank, that may start from the first position to the last position. So you can see that the order is important, right? Their order is important, and you can substitute those orders, like very unsatisfied, you can substitute that with 1, or the very satisfied, you can substitute that by 5. So you can substitute them by numbers, but those numbers are just going to represent their order, right? But they're not going to represent the absolute quantities. Like the class grades, right? So in the class grades, you can have A plus grade, A minus, B plus, or B minus. So you can have different grades in the class. But these grades, they have been arranged in order, right? So these grades, they have been arranged in an order. But if you substitute these grades by 1, 2, 3, 4, 5, that is not going to change their statistical meaning. It is only going to symbolize their relative position onto the scale. So the ordinal scale is that which involves the rank ordering and classifying of individuals. Now, in the ordinal scale, as we discussed, that it is used to arrange or rank individuals ranging from highest to the lowest according to the variable, like the consumer satisfaction from highly satisfied to the highly dissatisfied, or from maximum to minimum. But these ordinal numbers, they may not indicate the absolute quantities, and the interval between adjacent numbers or categories cannot be assumed to be equal. Now here we can see that, for example, this is an ordinal scale, and we have different categories here, and you can see that the interval between these categories is not constant. So we cannot exactly define the interval between the categories or between units on the scale. We can just order them, right? So you can see that this interval between the first and the second category is not the same as the interval between the second and the third category, and same is the case for rest of the categories. So it's not certain that this distance or this interval between the units is going to be constant, right? So it can be different. So in ordinal scale, we are classifying the individuals, and we are ordering these classes or categories in a specific rank order, but the distance or the interval between the orders is not going to be constant. It's not going to be uniform. Now we take the example of a famous ordinal scale, which is the Defar scale, and it records the abundance of different species. Like the dominant, it may be represented by number 1, abundant species, which may be represented by number 2, frequent species, which may be represented by number 3, occasional, which may be represented by number 4, and rare, which may be represented by number 5. So here you can see that they are arranged in order, and this number has a significance in terms of order only. So 1, 2, 3, 4, 5, dominant to rare. But you can see that abundant does not mean twice occasional. It is just above frequent and below dominant. So in the ordinal scale, the distance is not constant, and distance cannot be measured or distance cannot be defined. We can only rank order them. Like the dominant, it is the most dominant. The abundant, it is less than dominant. It is less frequent than dominant, but it is more frequent than the frequent. And then we have the frequent, which has less frequency than abundant, which has higher frequency than occasional. Then occasional, which is less common than frequent, but more common than rare. And then we have rare, which is least common. So we have these classes arranged from maximum to minimum. So 1 represents maximum and 5 here represents minimum. But the distance between these is not said to be constant. So we cannot say that frequent means twice of abundant, or we cannot say that occasional is twice of abundant or frequent is twice of dominant. No, we cannot say that because that distance is not uniform. So this is one example to explain the ordinal scale. Then we have another example like the CGPA of students starting from 4, which is the highest, and 3.99, 3.98, 3.97, 3.96, 3.95, 3.94. And here you can see the class ranks. So class ranks in this case, they represent the ordinal scale. For example, the first student in the class that scored 3.99. Then the second student in the class who secured second position, the CGPA of that student was 3.97, and then the student who secured third position had a CGPA of 3.96, and the student who secured fourth position had a CGPA of 3.94. So here you can see that we can identify their ranks, we can identify the highest CGPA, the second highest CGPA, the third highest CGPA, and the fourth highest CGPA. But the interval or the distance between these ranks is not constant. We cannot precisely measure the distance between these ranks. So this is just one example to show the ordinal scale. So in the ordinal scale, the order is meaningful, but we cannot assume the differences between adjacent scale values to be equal. It can be equal, it can be unequal. So we should not assume that this distance is equal distance. So this is the ordinal scale, which is our second level of measurement. Now we have our third level on the scale of measurement, which is the interval scale. And interval scale involves a rank ordering of data like the ordinal scale, so it incorporates the property of the ordinal scale. And what is additional in the interval scale is that it allows recognition of interval, that how precisely far apart are the units on the scale. So on the interval scale, we can find out the exact interval or exact distance between different classes on the scale, between different units on the scale. So this is something which was lacking in the ordinal scale, but this is incorporated into the interval scale. So here you can see that you have the interval scale, and on the interval scale the distance between the units are equal. So it is not just the rank order, it is a proper scale on which you can see different units, and your values or your individuals from the statistical population, they may fall on any of these units, but we will be able to precisely measure their distance, that how much far apart they are on the scale. So the difference between the values of 8th and 9th point on the scale is the same as that between 2nd and 3rd. So the distance between different units is the same. So this is the interval scale, which has a proper scale with equal units, with measurable units on the scale. In the nominal and the ordinal scale, they were mere classifications. In case of nominal scale, the classification didn't have any rank ordering, but in the ordinal scale, the classification had rank ordering. But in the interval scale, we actually have the numerical values, we actually have the numerical units. And these numerical units, they can be represented on the scale, and these different units on the scale, they have got their meaning and their distance can be measured. So this is the difference between the interval scale and the previous two scales. Now the thing which is lacking in the interval scale is that interval scale does not have an absolute 0 point. And therefore it is not possible to say that 9th value is 3 times that of the 3rd, right? So we cannot multiply or we cannot divide the units, we can only add or subtract them. So the intervals, they can be added or subtracted, they cannot be multiplied or divided because it doesn't have an absolute 0 point on the interval scale. Now we are going to see a simple example to understand the interval scale, and we are talking about the first arrival dates of 4 species of warblers in this case. So the first species arrived on first day. So you can see that our scale doesn't start from 0. Our scale starts from first day, and first day is that day on which first member of the species 1 has arrived, right? So this is going to start our scale, so this is going to be our first day. And then we are going to count the days, first day, second day, third day, and we see that how these species arrive on this scale. So the first species arrives on first day, and this is going to start our scale. And then we have the species 2, and the species 2 is arriving on 5th day, right? So the species 2 is arriving on the 5th day, and then species 3. So the first member of the species 3 is arriving on 10th day, and the first member of the species 4 is arriving on 15th day. So here we have our interval scale, and you can see that the interval scale in this case is comprised of the units, which are 1 day. So every unit on the interval scale is equal, and this is 1 day. And the arrival times of the species, or which are the observations of our experiment, the observations of our information that we are going to collect. So our observations, they fall on this scale. The first observation falls on first day, the second observation falls on 5th day, the third observation falls on 10th day, and the fourth observation falls on 15th day, right? So we have a scale, and we can find out that what is going to be our observation for a specific item, for a specific unit in the statistical population. So here we have these species, and we can actually measure the distance between these different categories, between these different species. Like we can say that species 4 took 10 days longer than species 2, right? So the species 4 that first arrived on 15th day, and the species 2 that first arrived on the 5th day. So we can say that species 4, it arrived 10 days later than species 2. But because we don't have a 0 point, so we cannot say that species 4 took 3 times as long as species 2, right? So this is the interval scale, and the interval scale is a proper scale with the uniform distance among units of this scale, and on that scale, on that unit, we can measure for our individuals in the statistical population, for our classes in the statistical population, like we have done here. So the interval scale, it involves names or categories, it involves order, which is meaningful, and the interval has same interpretation throughout the scale. So whatever scale you have, the interval between different units on the scale, it is going to have same interpretation throughout. But what is lacking in the interval scale is that it does not have a true 0 point, right? So this is our interval scale, which is the third scale. Now we move on to the ratio scale, which is the highest level of measurement, right? So this is our fourth level, and this is the highest level of measurement, and it incorporates the properties of interval, ordinal, and nominal levels. And what is additional in the ratio scale is that it includes an absolute 0 point, right? So it has an absolute 0, therefore all mathematical procedures are possible. You can add, subtract, you can multiply, you can divide. So because it has an absolute 0 point here. So this is the highest level of measurement, and all kinds of mathematical procedures are possible on this scale. And this scale usually represents the measurement of different objects, like measurement of length and measurement of mass. And we can confidently say that the length of 150 millimeters is 3 times as long as of 50 millimeters, because we have an absolute 0 point here. So this is the highest scale of measurement. Here we can have a quick comparison of the 4 levels that we have just studied. So the property categorizing, it is present in all of the 4 scales. Rank ordering is absent in the nominal scale, and it is present in the other scales. Then the interval is absent in nominal and ordinal, that we can measure the interval, right? So measuring the interval is absent in the nominal and ordinal scale, but it is present in interval and ratio scales. Then the distance between the intervals, or between units of the scale, It is absent in nominal and ordinal scale. We cannot precisely determine the distance, but in the interval and the ratio scale, we can precisely determine the distance between two observations from our data. And the addition and subtraction, it is possible in the interval scale as well as the ratio scale and the 0 point. So none of the scales has 0 point except the ratio scale. And the mathematical procedures, all kind of the mathematical procedures, subtraction, division, multiplication, addition, they all are possible only in the ratio scale, right? So the ratio scale is the highest level of measurement, and it has properties of all of the scales, in addition to having a 0 point and a possibility to be performed with all the statistical and mathematical procedures. So here is a quick look of the scales of measurement. So today we have discussed the types of the variables, the continuous and the discontinuous variables, and then we have discussed the scales or the levels of measurement, which are for nominal, ordinal, interval, and ratio, and these levels are hierarchical, and the nominal scale is the most elementary scale, and the ratio scale is the highest level or the highest scale of measurement.